Hello everyone, welcome back. So today in this video, I will discuss an example problem for finding the stationary points of a cubical function. The function I have considered here twice x cube minus thrice x square minus 12x plus 4. So this is the function I have considered for this example problem. So the objective here that we have to obtain the stationary points of this particular function, and then the second objective is that we have to also obtain the nature of the point. Okay, so nature of the stationary points. Okay, so whether the stationary points are a minimum one or a maximum one or an inflection point. Okay, so we have to obtain the nature of the stationary points and after obtaining the stationary points. Now, what is stationary points? The stationary points can be obtained by applying the necessary condition for optimality. Okay, so what is the necessary condition for optimality? The necessary condition for optimality is the first derivative. Okay, the first derivative is 0. Okay, so for the points where the first derivative is 0, those points will be called as stationary points, okay, or stationary point. So the first derivative is 0. So we'll apply the necessary condition for optimality and then we'll obtain the stationary points. Okay. So necessary condition is the first derivative is equal to 0. So take the derivative. So this is the original function. This is the original function, cubical function. Take the first derivative. The first derivative is 6x square minus 6x minus 12 equal to 0. And if I simplify, then I will be getting x square minus x minus 2 equal to 0. And this is a quadratic function. So I can obtain the solution of this function or root of this particular equation. And if I obtain, then I will be getting two that roots. Okay, so one is at x equal to 2 and another one at x equal to minus 1. Okay, so there are two roots of this particular problem, or you can say that there are two stationary points, one at x equal to 2 and one at x equal to minus 1. Then let us obtain the function value at x equal to 2, it is minus 16, and x equal to minus 1, this is 11. So we have obtained the stationary points and we have also obtained the function value at stationary points. Now what is the next objective? The next objective is that we have to obtain the nature of the stationary points. That means whether the points we have obtained is a minimum point, a maximum point, or an inflection point. So for that, what I will do, or what we will do basically, that we'll obtain the higher order derivatives. Okay, so let us first obtain the second derivative. So second derivative of this function is 12x. This is 12x minus 6. So this is the second derivative. And let us obtain the value at x equal to 2, that is equal to 18, and x equal to minus 1, that is minus 18. The second derivative value is not 0. Okay, if it is 0, then what you have to do basically, that you have to obtain the next higher derivative. That means I will go for third derivative, then fourth derivative, then fifth derivative, something like that. But as the derivative value is not 0, so we can stop here, and in this case the n value is 2. Okay, it's a second derivative, so n is 2. So n is 2. So this is second derivative. So n is 2. Okay, so n is 2. What does it mean? That means n is 2, n is even. So if it is even, then what we will see basically whether derivative value is positive or negative. Okay. So in this case, at x equal to 2, the derivative value is positive. So therefore, that particular point is a minimum point. Okay. Or you can say it's a local minimum at x equal to 2. At x equal to -1, the derivative value is negative. So we can say, or we can say that the at x equal to 2, it is local maximum. So as you know that if n is odd, so in that case the stationary points will be an inflection point, but here n is equal to 2 and it is an even number, and therefore the stationary points will be either a minimum one or a maximum one, and here that x equal to 2, this is positive, so this is a minimum point, and x equal to -1, and this is negative, so that is maximum point. So finally what we can conclude, the cubical function has a local maximum at x equal to -1 and local minimum at x equal to 2. Okay, I hope this is clear. So we have solved this particular problem. We have obtained the stationary points and by applying the necessary condition for optimality, and then we have applied the sufficient condition for optimality for obtaining the nature of the stationary points. Thank you.